Welcome back, everybody, to this episode of the DIY Maker. Today, we're going to undertake a little bit different project here on the DIY Maker channel. What we're going to do is we're going to upgrade this high current DC outlet. Right now, the one I have on my truck is a 50 amp. It uses a SB50 Anderson DC connector here that goes directly to my battery. We're going to upgrade that to the SB175 connector and a really nice weather-tight housing from a company called Trailer Vision. This is a very nice rugged housing that's going to offer some protection for this big connector when we're not using it, and then just give us a flip open door when we do need to access it. So pretty stoked to get this put in. And one of the things we're going to have to do, though, is you're going to have to remove at least the headlight on this side, and then this lower bumper valance here is going to have to come out of the way, at least enough to get the holes in place for this bracket. So let's get to it. Now that we've got this valance sheet metal so that we can at least pull it out of the way to drill our holes to mount the bracket, we're going to delete on this 50 amp install that was in here previously. Okay, I've got the mounting bracket for the connector in place where I want it. Just need to square it up a little bit. And then I'm going to use a transfer punch, which is this tool right here. These have a constant diameter and then a center punch in the tip that allows you to transfer a hole pattern onto the place where you want to drill. So I'm going to pick up each one of the holes in the connector bracket and then transfer that. And I've also clamped the bracket in place so it's not moving around while I'm banging on this with a hammer. First thing we're going to do is go in with a slightly smaller drill bit. Yeah, this bumper I built is 1/4 inch thick steel. It's no joke. What we're going to do is change bits, go up a size to clear the screw that we're going to use. Then we're going to do this for all four. Looks pretty good. The only trouble is because of this angle right here, I've got to drop this down a fair bit. So I might not have long enough screws, but I do need to create a spacer to get this so it can open and close. I'm going to do another test fit. Turns out I don't have any spacer material that's really appropriate for this, so I'm going to order some, but for now, to get this mapped out and the wires laid in, I'm going to go ahead and just use some nuts to temporarily space this down and get it where I want it. First thing we're going to do is we're going to prep this 1/0 cable. We're going to cut through the insulation very gently. We don't want to cut all the way through to the copper. That's the good stuff. And if we bend it, we see it hasn't severed. To get that insulation off. There we go. And then we're going to crimp. Then we're going to use some glue-lined heat shrink tubing and seal this up nice. And there you have it. Now we're going to take this one, put it right in our housing. There we go. Now we're ready to secure this connector and the lower plate on, and then we can bolt this in the truck and see where these wires end up. All right, got our cables here, and we're going to get these nuts back on the way we had them before. And then we'll get this in position, and then we're going to start routing these wires. Okay, I've got these big flexible 1/0 cables routed through the radiator support. We're going to put some heater hose around these where they go through the sheet metal, just to give them a little bit greater abrasion resistance. But for now, we're going to get this connector in place and then figure out where these high current cables are going to go. Okay, I put some marks on these wires. I've got a black line here. That's going to be my cut length for the ground wire. And this is going to be my strip mark. And then on this one, we're going to go right to this terminal on the circuit breaker. And that is my cut length there and my strip line there. And then we're going to have enough of this black wire left to make a short jumper to go down to here to the circuit breaker. And then we should be good to go. We're going to put a red heat shrink over this whole thing. And that should button this up. We're going to cut there. We're going to strip to there. So I'm working on this jumper cable for the low voltage, high current connector that I put on the front of the truck. One of the things I want to make sure is that I get the clocking on these terminals right, so that it's not trying to twist this big cable, because this is not, even though this is a very flexible cable, it's not very forgiving for not having your connectors clocked the right way. So I know that this is the negative, here's the negative here, and I need this flat part of the connector clocked like that. So as long as I get that right on both of these, they should pop right in the housing, and then this connector will be done. I would be remiss if I didn't take a moment to thank my friends at DS18. They are the reason I had enough cable left over to also make this enormous 8.5 foot 2-conductor 1.0 or 1.0 gauge jumper cable for my connector system using the SB175s. This is not an insignificant amount of copper, and this is all pure oxygen-free copper. And DS18 was kind enough to donate it to the DIY maker for use with this truck project. And I gotta say, not only did I have enough to do the front end of the truck and make a really professional, nice installation there, but they also gave me enough to do a really serious jumper cable as well. So this allows me to remote high current DC devices in a way that I otherwise wouldn't be able to. So I'd like to thank DS18 for the gift of cable and believing in this project and seeing it through to the end. So thanks, guys. Also, if you're interested, I'll put a link to where you can buy this on Amazon as well if you want it for a project, either putting an amplifier in your car or truck, or any other project that requires really good, supple, easy to form, high current cable. And again, this is the 1/0 oxygen-free copper solution. It's really high-end cable. Okay, the last two things I want to do is kind of armor these cables a little bit. You'll notice there was a potential rub point here with this AC coolant line going to the evaporator. I just took a piece of heater hose and wrapped this cable with heater hose. I just slit the hose down lengthwise and slipped it over. The other thing I want to do is the edge of this sheet metal opening on the radiator support. I'm going to put an edging on that is meant for protecting sheet metal edges from wire. But once those two things are done, this project will be a wrap. Well, folks, that's a wrap. I got the edging in. I had to go with 4 separate segments in order to get it to fit properly. The radius was just too tight, but I think it came out really well. I'm pretty happy with it, and we're going to get some adventuring done.